Welcome to Season 3 of the Soundstage Audiophile Podcast. Last year, host Jorden Guth got a crash course in the fundamentals of hi-fi from enthusiasts, journalists, manufacturers, and music industry professionals alike. And those lessons will continue, but this year, Jorden will also get a history lesson from the legends who were there from the giddy-up and who made hi-fi what it is today. So with that out of the way, here's Jorden and this week's guest.
Hello and welcome to the Soundstage Audiophile Podcast. Today we are back with Paul Barton for the second half of our talk. On the previous episode, we talked about his introduction to the National Research Council, the NRC, in Ottawa, Canada, and meeting Dr. Floyd Toole. Paul, once you met Dr. Toole, you started bringing your speakers down from Waterloo to Ottawa to have them measured. Is that correct? Or was there a bit of time before you started measuring in the anechoic chamber?
I immediately brought everything I had that I was currently building to NRC, and every single one of them got improved once I had a chance to take a crack at it. And
did you know what you were listening for? Or did you know like what you wanted to measure for?
Well, in general, even back in those days, I don't know if I recognized it in describing it in this way, but a speaker is a window through which you see the acoustical event, a clear window, doesn't have tint or color.
Yeah.
And so the presumption is that whatever the original sound is, that's what the speaker has to reproduce. And the only way, by definition, to do that is for all the frequencies to be of the same amplitude as they are from the original. You can't deviate from any change in the relative relationship between one frequency and the other. They must all be the same, assuming that the source of that recording had the same rules applied.
Yeah.
And that's an assumption you have to make. It's not always the case, by the way, but it's an assumption you have to make. And so, the first thing you look for in an anechoic measurement is, because there's no room, the only thing you're measuring is the energy coming from the loudspeaker. No other energy is being reflected back off that the loudspeaker is producing. So so if that's a good reproducer, there should be no deviation from one frequency to another in terms of energy. It's like if you put on a pair of glasses and the world becomes much brighter. Well, that's okay if that's what you want it to do. But as a speaker, a reproducer, in order to reproduce sound accurately, you can't put a yellow tint on it. You can't put blue tint on it, because that's going to skew what it looks like naturally. Yeah. Now, if you want to take something that's natural and add tint to it, that's fine.
Sure. But as long as you're starting from the natural base.
Right. Once you have a speaker that's already yellow in tint, how do you take that away?
Yeah.
Like, you don't have if you're an engineer, you can do that by doing measurements and being able to go into the system and make adjustments. But I want to give the customer a good starting point, and that is, what goes in comes out, no more and no less. And so, and at the end of the day, if a customer doesn't want that sound, there's all kinds of ways that you can change the music, but at least the speaker is true to being natural and normal, acoustically transparent.
So when you first started going to NRC and you first started bringing all those products, was there major kind of design realizations that you had that you said, like, I need to change this, or I need to do this, or this is much better at kind of giving that natural sound than what I'm currently doing?
Well, one of the things that I couldn't do before I went to NRC was to really take a micro look at what was going on. My measurement system before I went to NRC was pretty much antiquated, in the sense that I could only do near field measurements in order to represent what the speaker itself was doing, and the measurement not being influenced by the environment that I had it in. And you can somewhat get rid of that by putting the microphone really close to the speaker. So I would do a lot of near field measurements and things, but that's not enough, because the way this, say, a two-way system or a three-way system integrates in space out in front of the loudspeaker, doesn't, by measuring it close to the speaker, doesn't tell you very much about the relationship between all the crossover points of each of the drivers. So when I got to NRC, I was able to do more of that. And so I could get a better idea of what was going on around the loudspeaker, not just by near field measurement of the loudspeaker. And I want to keep the environment out of the equation when I'm doing measurements, either near field or whether I'm doing measurements in an anechoic chamber. So as I did more measurements and started to become familiar with the results you get in an anechoic chamber, if you look at the history of PSB and the evolution of products, you can see certain features starting to be introduced. One in particular is I started using felt, a felt pad, about a 1/4-inch thick felt pad around the tweeter. And if you look at our new Passive 50,
Okay.
that's our anniversary product, that has felt around it because we wanted to emulate a product that I produced back in 1974 at the time that I first started going to NRC as a vintage product. And it has black felt sort of around the tweeter, and the tweeter is buried in the felt. And then the grill was designed to be an integral part of that, and it fit in around the felt, so that the topology around the tweeter was very smooth and it had absorption material around it. And that helped to reduce a phenomena called diffraction. And what happens is, imagine the tweeter on the baffle. So when the tweeter moves out, it creates a positive pressure which travels at the speed of sound to you in the room.
Yeah.
But because it's a hemispherical radiator, it also radiates in a hemispherical radiation, so that energy from the tweeter not only goes out to you, it also moves across the baffle. But when it gets to the edge of the baffle, there's no more baffle there. So that pressure becomes a decompression, because now there's no baffle to reinforce that wave moving across it. And because that's a disturbance in the air, that becomes another source.
Interesting.
And so because the distance could be different, the time it takes for the energy to move across the baffle and get to the edge, and the time it takes for you to get to you, could be as much as a half a wavelength difference. All right. So now that little disruption that has occurred when the energy moves across the baffle, when that disruption occurs in time, that distance, and it's half a wavelength at, say, 2 kilohertz, and half a wavelength at 2 kilohertz is about 3 inches. 2 kilohertz is about 6 inches long, so half a wavelength is 3 inches. So if that tweeter is 3 inches from the edge of the baffle, the sound will move across that and cause a signal which is delayed in time by half a wavelength. And so that will cause a perfect cancellation, because the sound that got to you, and then half a wavelength later, the sound that got to you off the edge of the cabinet, causes a cancellation after the first half cycle of the energy that it's producing.
Interesting.
And it's called diffraction. So by putting felt on there, now the energy that's moving across the baffle gets absorbed. You know, it's damped by that damping characteristic of the felt. So by the time it gets to the edge of the cabinet, it's somewhat reduced in amplitude or energy, so that when it does diffract, it's not as intense. So it can't cancel the original signal as much.
Interesting. Now, when I'm looking at these passive 50s, I just brought them up here. One, they look really cool. They remind me of my dad's stereo system.
Well,
that
that's
he had.
Exactly what that is.
Yeah,
you know?
Growing up. But I also noticed that the tweeters are offset. They're towards the inside edge of the speaker, as opposed to like directly in line with the woofers.
Yeah. Well, so
is that also to kind of?
Well, it's to kind of skew that point where they're diffracting. Now, okay, the diffraction off one side will be different frequency than the diffraction on the other side.
Got it.
If you put it in the center, then the diffraction will be the same on both sides. Now, over time, we've kind of taken another approach to resolving that issue. And that is, you'll notice that all of our tweeters now have a waveguide on them.
Got it.
And so now that energy is reduced by virtue of the fact that it's somewhat narrowed in dispersion. And at 90 degrees off axis, there isn't the kind of energy there would be if the dome was completely flush with the surface. So we've just taken a different approach, but trying to address the same issue.
Are the things that you measure today in an anechoic chamber, what you're looking for in the speakers, are those the same things that you were measuring back in the day? Or has that changed over the time?
No, the ultimate result or goal has always been the same. And I said it earlier, is that the speaker has to be acoustically transparent.
Yeah.
Should have
without tint.
Yeah. You see a lot of, or hear a lot of people who talk about, oh, that speaker's made out of walnuts, so it's going to have beautiful wood sound. Well, maybe it does, but that's not what a speaker's purpose is.
Yeah.
A speaker is a transducer. It changes one form of energy into another form of energy. And it does that, it's supposed to do that in a way which that energy doesn't change. It goes from electrical energy into acoustical energy. And that's what a transducer is. And transducers are the weakest link in any system where you're turning one form of energy into another. There are always inefficiencies involved. There are always losses involved. If you could have a perfect transition, that would be
a miracle.
A miracle. Yeah, so that's the gist of what the objectives are. Now, as far as being able to do something about what the ultimate goal is what's really evolved over the years. And that is in terms not only of being able to do measurements, but to be able to do something about the measurements that you get. It's one thing to measure something, but if you don't know, once you see what it's doing and you want to change it, the challenge is how do you make it do what you want it to do? Even though you measure it, you say, well, it's wrong.
Yeah.
Okay, well, now that it's wrong, how do I make it right?
Yeah.
And that's what I've learned over the years to do better and better as time goes on. Things like the orientation of the drivers.
Yeah.
And the crossover. Those
putting
are
the tweeter below the woofer.
Yeah. And with an anechoic measurement and over time with experience in the anechoic chamber, you start to really get a three-dimensional, in my own head, a three-dimensional map of what the speaker's doing all around it. The total energy the speaker's putting out. This is something we call sound power.
Yeah.
And you can measure these things and compare them with other loudspeakers. You can get a lot of loudspeakers that if you measure them in the anechoic chamber on axis, they're perfectly flat. But then you do their sound power, the total energy the speaker's putting out, not just the energy coming directly from the loudspeaker. Because keep in mind that in a room environment, you don't only hear the direct sound from the loudspeaker.
You hear reverberations.
You hear a part of the total sound power of the loudspeaker. Yeah. All the energy the speaker is putting out. In an anechoic chamber, you're only looking at one specific spot. And so as time goes on, I start to learn better about how to use topology and crossovers to give me the best phase characteristics of the loudspeaker at the crossover point, creating a situation where the speaker arrangement allows for the most practical and realistic listening environment, which is not everybody sits down to listen to loudspeakers. Sometimes, and the speakers are always in one place. So you don't want to have to change the height of your speakers when you stand up in a room. You want the speakers to be kind of universal for sitting listening or standing listening. Some speakers who have tweeters, say, above, they measure really well on axis, but if they don't use the right topology and the crossover network and the phase and the crossover point, then when you stand up, there could be a big notch in the response there.
Interesting.
And this is something that Dennis was talking about earlier, and that is that it's something you can really notice. And I like to think that music is kind of a social activity sometimes. It's not just solitary activity. So when it's a social activity, you could be dancing, or you could be standing up, or you could be walking around. I keep that in mind when I'm voicing the speaker, because I can control somewhat, particularly at the crossover point, how that speaker's directivity feeds into the room. And I find that really something I've learned, and it has evolved over the years. The first time I ever did that arrangement was on a speaker we called the Project B2, which I designed in about 1978. And it was sort of the beginnings of how PSB's setups and complement of drivers and crossover points and crossover topology has evolved over the years.
And would you say that is the kind of most important element of the speaker design? It's essentially how the crossovers are kind of set up, or is there another kind of element that's kind of more important to get that kind of tonal balance of your speaker?
Well, no, the most important thing is what you're just highlighting there by your question is that if you don't get the frequency response right, you might as well go home. You can have you can have really, really low distortion, but if the frequency response isn't flat, it will fail in a listening test, even though the one that has flat response might have more distortion, because we prioritize what's important and what's not when it comes to our brain processing and being able to understand or make it so it sounds natural as opposed to sound artificial or colored. When we put yellow tint glasses on, we know it's yellow tint. Yeah. We can see it. Well, you can also hear yellow tint when you add colorations to something. And I tend to gravitate towards making a neutral loudspeaker and let the consumer put the sunglasses on when he wants to listen with yellow or blue.
You talk about the natural sound. We kind of joked earlier about the idea that a speaker manufacturer might have like a walnut cabinet, so it has the rich sound of walnut or whatever it may be. Does that lead you to use natural materials in your products, or does technology in kind of like new materials and even other technologies like room correction, do those come into play in PSB speakers as they become available?
Well, yeah. As far as room correction is concerned, I've been very active in working with companies and working with, particularly with NAD, implementing Dirac in their system. And they asked me to do all the microphone calibration files for the microphone that comes with their equipment to do calibrations. And let me just say that if you've got a really good loudspeaker and you put it in, not really good, but if you've got a good loudspeaker and you put it in a room, the only correction you probably really need is anything below about 300 hertz or 500 hertz. If you start trying to fix things above the high frequency, if the speaker isn't flat at higher frequencies, trying to fix the speaker is not a good solution. So you have to have a pretty good speaker over the whole bandwidth in order for you to realize the best results of a full bandwidth EQ for, say, a company like Dirac or Odyssey. And if you fix the low frequencies, that's where the room has the most influence. At higher frequencies, more of a reverb time and echo problems or reflections in the room, which are more related to sounds that arrive at different times rather than just being out of phase with each other, although that's sort of the same thing. But at lower frequencies, you get cancellations based on the size of the room's dimensions, and the wavelengths that are trying to be reproduced in the room. So you get large deviations in frequency response at low frequencies in small to medium-sized rooms, where the wavelengths that you listen to, where most of the music is at low frequencies, are somewhat related to the dimensions in the room. You get a lot of chaos going on. And Dirac can really help to fix that in order for you to have the right frequency response for the positions that you or the positions that more than one listener might be in the room. And Dirac allows you to tune it for larger areas, which obviously won't be as accurate for any one area, but certainly will help.
Yeah.
And as you get smaller and smaller areas, the accuracy becomes better. So listeners who have Dirac might want to even set up several different setups where it's for a wide listener group, it's for a small group, or it's for an individual. You can set different parameters for listening or playing back. As far as what was the beginning of your question?
Well, and you kind of got to there.
Okay.
It was the technology. As technology evolves, how does that kind of change the way that you design and build speakers? And in my questioning, I kind of took two paths on that. I was thinking about the technology of the materials used,
yeah,
and whether you are beholden to like natural materials, whether it be PSB will only use wood or only use XYZ, or if new materials as they come out are something that you investigate, like carbon fiber or, I don't know, interesting metals or
it depends on what you're talking about. If you're talking about a driver, you can get a result with many different methods. And we use over the years, and certainly now, we use a lot of different cone materials. Some have some advantages over other advantages, but in general, what I try and do is make the driver and the system work as much as a piston as it can over the widest operating range. And certain materials behave better in that regard than others, where, you get certain cone materials that, behave in a nasty way when the wavelengths get smaller than the physical size of the driver. The driver physically starts to get in the way of itself.
Interesting.
Because the frequencies it's producing have wavelengths in air that are smaller than the physical size of the driver, and then you start running into problems. So I'm not too focused on different materials. Some materials work better than others. You might want to choose some materials that have higher stiffness and lower mass, because that gives you an overall output sensitivity that's a little better, and that's always a good thing. As far as cabinet materials and woods and that, the whole philosophy behind the cabinet is you don't want the cabinet to do any talking. Only the drivers should do the talking. In order to accomplish that, maybe we should start building cabinets out of concrete.
Interesting. Because
then the cabinet would do absolutely no talking.
I don't know if you've seen the monitor audio hyphen speakers. They're these like H-shaped speakers, and they're not quite concrete, but they're almost there. It's like a stone material.
Yeah.
Quite heavy. I wouldn't want to lift those up 4 flights of stairs to the CES.
Yeah.
The way that you did the dampening panels.
Well, there is a point of diminishing return, and you can overcome some of the mechanical issues with woods and things like that, or materials that you use to build the cabinet, by putting proper bracing inside, using, good dense materials that don't want to move or vibrate very, very easily. They make good materials for cabinets. We use low formaldehyde MDF, which is called medium density fiberboard. That's what MDF stands for. And you can also get HDF, which is high density fiberboard. And then you can just get regular Rexwood, which is low density fiberboard. So it's kind of a point of diminishing return. You could make it out of concrete, but I'm not sure many people would hear the difference because of the subtle improvements that it does make. So I tend to want to focus on the things that are most important. And as I mentioned earlier, the number one is flat frequency response. Number two is good directivity, which is what we talked about: sitting down, standing up, having some control over the directivity of the system. And then the other ones are things like distortions, intermodulation, harmonic distortion, and of course, output capability, sensitivity, which is amplifier power, and potential output capability. Like you can have a speaker with a 4-inch woofer that's designed to handle 500 watts. I don't care what you say, it's not going to play very loud, even with 500 watts on it. So it's a matter of just balancing off all the different things to give you good balance between power handling, low distortion, flat frequency response, and good directivity. And so in order of priorities or preference, flat frequency response, good directivity, which includes the sound power, which I mentioned earlier, and low distortion and sensitivity. And believe me, those are real challenges. You know, when you got to do all of those things at the same time. I mean, some people do one thing really well, some people do other things really well, but to get them all to work together, that's the challenge.
Quite a lot of people are familiar with Dr. Floyd Toole's book on speaker design and all the different components that are necessary to kind of produce good quality sound. I guess my question is, you worked very closely with Dr. Floyd Toole. You have your own experiences and your own information. If you were to write a book, would you come to the same conclusions, or would there be differences?
Well, no, because as I've described earlier, the goal is always the same. How you approach that, like Floyd has really profiled what the goals and results should be, what listeners prefer. And my job is to try and get to that level where it's taking care of all of those things. I don't deviate at all from the research and the results of that research that Floyd has documented very well in his book. He's actually working on a new version of the book right now.
Oh, yeah?
Yeah, he just moved to Ottawa.
I heard. Yeah.
Yeah, he moved back from California to Ottawa. And I talked to him the other day, and he's anxious to meet up with me at the anechoic chamber. And I think Doug is going to do some other stuff with us there.
I believe so. I think there's some really cool things in the works that I'm excited to see.
Yeah, I'm looking forward to it. And Floyd called me I called him. No, he called me actually the other day, and just to tell me he's in Ottawa, getting settled. He hasn't moved into his new place yet because they're still building it. So he's staying in a suites hotel somewhere in Ottawa for a little while until he gets into his new place. So he called me, and he's anxious to go by and see what NRC. He hasn't been there for a long time, so it'll be nice to get together with him there.
That's amazing. I mean, we've already taken so much of your time, and I don't want to take up too much more. We didn't even get to talk about the PSB headphones, which I'm super curious about, and I have so many other questions. There's a million other things that we can ask you.
Well, let me just talk very briefly about the headphone, because it does relate to some of the stuff that was being done at NRC way back when Floyd was there.
Yeah.
In 1987, Floyd and I went to England to an AES conference. And one of the tasks that Floyd and I had, we went together to AES conference in London, England. And one of our tasks there was to try and follow up on something that the Europeans had announced. It was something, I think it was called the Eureka Project. And it was the European community, many countries involved, aligning themselves to do pure research in new technologies, and there was funding available for that. And someone in the Canadian government had cited this, and Floyd found out that maybe Canada could join in with the Eureka project and become a part of this research, because KEF and B&O actually had started a consortium to do this kind of research. And so we went to London, England, and we went to the Canada consulate to find out about this grant program that the Canadian government had cited, and Floyd had found out about it. So we went to the Canadian consulate when we were there for the AAS in 1987, and they kind of chuckled, because they said that whoever was doing that, and I don't remember all the details, was kind of a little bit overzealous and didn't really know what he was talking about. So Floyd at that time was determined, okay, we're going to do this research ourselves. And it was to do with, developing a smart loudspeaker, a speaker that could adapt to the environment. Oh. And so Floyd lobbied a whole bunch of companies here in Canada, and even invited people from the United States to form a consortium to do research. And 4 companies ended up being a part of that. And that was Paradigm, API, which is Audio Products International. That was Energy loudspeakers, Mirage loudspeakers, Sound Dynamics loudspeakers. They were the manufacturer of those brands. Another company called State of the Art Electronics, which is a gentleman out of Ottawa who has a company called Soda. And he used to build all the high-powered studio monitors for the CBC across Canada. So he had been doing a lot of research and tuning and things like that in the anechoic chamber. And he, of course, was also interested in getting better sound reproduction by doing room correction and finding out what a smart loudspeaker, how it could adapt to an environment. So we started a project called the Athena Project, and it included the 4 companies, Paradigm, API, State of the Art Electronics, and PSB. And along with NRC and IRAP, which is an industrial research assistance program here in Canada, we funded, I think over the 2.5-3 years that we did this, probably funded maybe $1.5 million into doing the research on this. And how does this relate to headphones? As I started this out, well, when you put a speaker in a room, the room has influence on the loudspeaker, particularly at low frequencies, as we discussed earlier, where all the problems in rooms are. And that's where we want to do correction. So we actually built NRC had a separate room built for the Athena project beside the original listening room, which was a variable room. You could actually change the room from a rectangular room to a square room to an L-shaped room.
Oh, interesting.
By moving the walls. The walls were movable, clamping to the ceiling and the floor and the sides. You had these special mechanisms for making the walls move. And so we could do double blind screen listening tests of listeners, and we hired some students from Carleton University in Ottawa. So in the evenings, we would pay them to do double blind screen listening and give us results under the umbrella of the Athena project to come up with what the ideal target function needs to be for a flat anechoic speaker, what it needs to be in a room. Because when you put a flat anechoic speaker in a room, you get gain at the low frequency and you get some attenuation at high frequencies based on the anechoic measurement. Yeah. And we wanted to know what that transition target curve needs to be. Oh, and by the way, when I start designing headphones, I realize, that target curve can work in a headphone because the headphone has no room. And the music we listen to on headphones is music that was recorded to be played back in a room on loudspeakers, direct radiating loudspeakers. And that's how the engineers and the musicians and everyone who made decisions about made it based on, let's make them sound the best they can, this music, when I'm listening to a pair of speakers in a room. Well, the room has influence, and we know what that influence is. So let's apply that to the headphone when listening to music that was recorded to be played back on speakers in a room. And that's what room feel is. And that is the target curve that Harman are actually basically using as well. They call it the Harman curve. And Sean Olive and Floyd Toole, Sean used to work with Floyd at NRC, and he went to work with Floyd in California after Floyd left the NRC. Yeah. And Sean was one who was also doing the work on the Athena project. So he took all of that. And when I designed the first headphone in 2011, actually, yeah, that's when I implemented the first room feel. And that was the first time that I was able to let Sean, because they came to a CES in 2011, or no, it was the CEDIA show in 2011. And I let Floyd and Sean, who came to our booth, hear the M4U2s for the first time. And I told them what I had applied. And now Harman and Sean are doing more and more research on headphones. In fact, Floyd told me the other day his latest book, the fourth edition of his book that he's writing right now, will include all of that stuff that Sean has done, and also all the subwoofer stuff that's going on. Todd Welty did all the multiple location subwoofer research for Harman. That will also be included in the new book.
Now, I have to ask, when is your book coming out?
Oh, well, my book would be more reminiscent rather than technical.
That is fair. I think the amount of knowledge that you have and the amount of connections that you can make just between the individuals in not only Canadian hi-fi space, but throughout the world is just absolutely incredible. That would be a fascinating read.
Yeah. There aren't many places I haven't been.
I think that would be an interesting read. Even just your take on the hi-fi industry. It doesn't necessarily need to be technical, although I know that you could speak to it, but just your view of the industry over the years. I think that would be a fascinating read.
Well, we can talk more about that maybe.
There we go.
You could be my ghostwriter and I'll tell the story.
Oh, amazing. Oh, I love it. The last question I have before I let you go for the day is, if we were jumping in the car, I know you travel quite a bit. If we were jumping in the car and you wanted to put on some songs for me or an album, purely for enjoyment, not to listen to, not to like test anything, but what would that music be? What would that kind of soundtrack to your life or the music that you're excited to share be?
Well, I'm a real fan of a lot of the older import music that came from Europe, especially in Scandinavia. Like a group called Exception was one of my favorites. EK is the spelling.
Okay.
And I don't think you'll find much. You'll find one of the leaders of that band still produced music, but the band itself never did. And, because I was sort of raised and reared on classical music, when it comes to really diving in and losing myself in the music, it's the classics that I reflect on. And maybe part of it's because of the memories I have about playing those pieces of music. Like when I had just turned 16, I got my driver's license. And as soon as I was able to drive, I joined an orchestra at the University of Toronto. Of course, I wasn't university age yet, but they accepted me. And I used to drive up every Saturday morning to the Edward Johnson building on University Avenue beside the museum, right beside the museum near Bay Street. And Bay and University, actually, that's where it is, Bay and University. There's a place just beside the ROM that is called the Edward Johnson building. So I used to drive there every Saturday morning with my violin and go down into the basement where they had a practice room. And Victor Feldman was the conductor of the Toronto Symphony at the time. And he was teaching classes at the University of Toronto. And one of the classes he taught was a class to teach conductors how to conduct an orchestra.
Oh.
Of course, in order to teach someone to conduct an orchestra, you kind of have to have an orchestra. and I participated. It was the University of Toronto Repertoire Orchestra, they called it.
Yeah.
And so every Saturday I go down in the basement of this Edward Johnson building and set up my music. But what they would do is they would put the music for the day on the stand. And so every Saturday it would be all sight reading. And so the conductor would be up there conducting stuff that we were just sight reading, one piece after another. So I can honestly say that I've played only once almost every piece of classical music you can think of.
That's amazing.
Now, some I've practiced and learned, diligently, but I can just say that, I've gone through them once at least. Because I spent so much time on Saturday mornings playing new repertoire that was all being sight read for this conductor's class that Victor Felbro was holding for University of Toronto students.
And with that, I have kind of a unique spin. What is your favorite song or music to actually play? Because you still play the violin fairly often.
I would have to say my favorite one is probably the Bruch Violin Concerto.
Okay.
Or the Wieniawski. Either one. And I kind of like the Bach Double Violin Concerto, but that's kind of fun to play. And I used to play it. I used to have a record of Yehudi Menuhin.
Okay.
A very famous violinist. And I had it on my dad bought it. It was a 78 recording. And on one side, Yehudi Menuhin was playing the first violin of the Bach Double Violin Concerto. And on the other side, he was playing the second violin. So I could play the first side and play with him as the second violinist on the Bach Double Violin Concerto. And so that's how far back I go in terms of, that recording was on a 78.
That's
Probably
amazing.
Don't see many of those anymore.
I love it. Paul, thank you so much. I greatly appreciate the huge amount of time you took. It was fascinating. I think everyone listening is going to get something out of this because there's just a lot. And I wish you all the best in the future. I think there's going to be some really cool things to come. And we're going to talk about a book in the near future as well from you. Maybe get you a ghostwriter in that. Yeah, okay. Well, before you go, I just want to say I enjoyed doing this. And, if you want to follow up with something later on, that's fine with me. Maybe we could have an entire episode on headphones. I'm sure of it. We could pick some topics and queue them up and do some work on that. And when we're in Ottawa, you should try and put some time aside and ask Doug when that's going to happen, because I'm sure he's going to be up there trying to, visit with Floyd. But when I go up there, I'm sure Floyd will come down. Maybe you should pop over. Yeah, for the anechoic chamber and all that. There's a video project in the works for that. So I know there's going to be some filming going on, so I'm excited for it. Should be good. Yeah, I'm looking forward to it myself. All right. Thank you so much, Paul. All the best. All right.